welcome to the deep dive. Today we're getting into something fundamental but maybe a bit unseen in software. Loop testing.
Right. It's like looking under the hood at the repeating parts of the engine.
Exactly. And our sources, they really focus on understanding and, validating these loop constructs.
These are the bits of code that run over and over. Super efficient, but also places where errors can creep in pretty easily.
Okay, so the sources talk about different types. Simple loops, nested ones.
Simple, nested loops, inside loops, concatenated, which are one after another, and even unstructured loops.
And each needs its own way of being tested, it seems.
That's the core idea. So our mission really is to unpack why loop testing is so vital, look at how it's done for these different types, and what kind of problems it actually helps us find.
All right, let's start there. Why is this deep dive into loops so important? What's at stake?
Well, the big one is making sure the loop runs the right number of times. Repetition issues, basically.
Ooh, like running one too many times or one too few.
Exactly. Our sources are clear. A small slip up here, maybe processing one less order or one more, can have really significant impacts down the line.
Okay, that makes total sense. Is it just about correctness, though?
No, not at all. Performance is huge here, too. Loop testing helps find bottlenecks, a loop that's maybe coded inefficiently.
Ah, so it could slow everything down.
Definitely. Imagine it running thousands of times when it doesn't need to.
Mm-hmm.
That can grind an application to a halt, especially under load. We've all seen websites lag, right? Sometimes a bad loop is the culprit.
And the sources mentioned something about variables, too, initialization.
Yes, that's critical. Uninitialized variables. Loops often use variables set up before your loop starts.
Right.
And if that setup is wrong, maybe the variable doesn't have a starting value or it's the wrong one. Well, the loop's behavior becomes unpredictable. Testing catches that.
Okay, so it's about accuracy, speed, and getting the setup right. How do we actually do the testing? What's the process?
Generally, you look at 3 key moments.
Yeah.
Getting into the loop, running through it, and getting out.
Entering, executing, exiting. Got it.
For a basic simple loop, the strategy is pretty systematic.
Yeah.
First, you try skipping it altogether.
See if it handles 0 iterations correctly.
Exactly. Then 1 pass, 2 passes, then maybe a few more, let's say A passes, where A is, less than the maximum B.
Okay.
But the really crucial tests are at the boundaries. Test B minus 1 passes, test exactly B passes the maximum expected, and then test B plus 1.
To catch those off by 1 errors, that makes sense. Testing the edges.
Precisely. Now, for nested loops, things get a bit more complex.
Loops inside loops, yeah, I can see that.
The approach is to start from the inside out. You test the very innermost loop first, using those simple loop techniques we just talked about.
Okay.
And while you do that, you keep the outer loops set to their minimum values, minimum iterations.
Right, so you isolate the inner one first.
Exactly. Once that inner loop checks out, you move to the next loop outwards, test it, making sure the inner one still behaves, and so on, peeling back the layers.
Like peeling an onion layer by layer. What about concatenated loops? The ones that run one after another?
Yeah, for those, the key question is, are they independent or dependent?
Meaning, does one affect the other?
Right. If they're independent, you can just test each one like a simple loop. Easy enough.
But if they're dependent, say the first loop calculates something the second one uses.
Then you have to test them together, more like a nested structure. Because the first loop finishing directly impacts how the second one starts or runs. Their behavior is linked.
Okay, that distinction is important. And the last type mentioned, unstructured loops. They sounded a bit messy.
They often are. The sources basically say these types of loops, maybe using lots of go-to statements, are hard to test reliably.
Because the path through them isn't clear.
Exactly. The flow is unpredictable. Often the best approach isn't just testing, but actually redesigning that code to be more structured, making it testable in the first place.
So this seems pretty thorough. Does loop testing catch everything, though? Are there limits?
Good question. The sources do point out some limitations. Loop-related bugs tend to show up more in sort of lower-level system software.
Okay.
And the bugs it finds, they're often not the most subtle logic errors inside the loop's main job. It's more likely to catch things like memory access errors right at the boundary or pointer problems. things the operating system might even catch sometimes.
So it's powerful, but maybe more for catching those boundary and setup type errors than deep logical flaws within the loop's task itself.
That's a good way to put it. Yeah, it's a specific tool for specific kinds of problems.
Okay, so let's tie this together. This deep dive really shows loop testing as a key piece of white box testing, right? Looking inside the code's structure.
Absolutely. It's about verifying those repeating parts, the loops, ensuring they do exactly what they're meant to, correctly and efficiently.
Making sure the repetitions are right, performance is okay, and those initial values are properly set up.
Precisely. It nails down those core aspects of how loops function.
When you stop and think about it, consider just how many loops are running constantly in the background of almost everything we use.
Oh, countless numbers. Your phone checking for messages, navigation calculating routes, streaming services buffering.
Right, it's all loops, 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 and their flawless execution is just assumed. It really makes you think, doesn't it? What other hidden layers of quality checks, like this loop testing, are keeping our digital world running smoothly? What else is going on under the surface that we never even consider? That's something to chew on. Until next time on The Deep Dive.
CTS is the